We're going to move on to part 2 of this lesson, where we talk about substitution again, but now with 3 variables, not just 2. So it can be more difficult, but some of the processes of it are the same. Whenever we try to solve for a variable, we need to make sure we have one variable all by itself in an equation that we can solve for that variable. So we'll start out with an easier one at first. For part A, we're going to solve these all by doing substitution like we did yesterday. So it says solve by substitution. If we look at all 3 of these, we have x plus y plus z equals 9, x plus y equals 3, and y equals 2. This one is a little bit easier because it already gives us a value that we need, a y value. The y value is 2. So this time we're actually going to work our way a little bit backwards and start from the bottom equation and work our way up. So we have y equals 2. We're going to plug that into the second equation right above it. We'll put the 2 up here for y, and that will make it easy for us to solve an equation with x. So we'll write that out as x plus 2 equals 3. So I'm using my second equation. And then we're just going to subtract the 2 on both sides, and it comes out to be x equals 1. So now we have 2 out of the 3 answers. This time we have x, y, and z. So we know that y is 2. We know the x is 1. Let's go back up to the top equation and use that one now. We'll plug in that we know that x is 1. So we have 1 plus our y value, which they gave to us, which was 2, plus z, which we don't know, equals 9. Then we just solve this one for z. So 2 plus 1 is 3, plus z equals 9. Subtract 3 on both sides. Oops. End up getting z equals 6. Now that you have all 3 of them, you can put them into one big ordered pair at x, y, z. We can say it's 1, 2, 6. Or if you don't want to do that, it's just fine to circle all 3 of them. We already know we have x equals 1, z is 6, and then we originally were given y equals 2. So I'll add that on as well. That's probably the easiest kind that you'll see. A lot of times they will not give you one of the 3 answers. You'll have to work for it. So if we go to part B over here, this one does not give you any of them. We have 2 variables at least in every single one of the equations. But we have to somehow create one equation with only one variable and then work our way through the rest of it. The easiest way to do this is to look at these bottom 2 equations and look and see how they are both by themselves with an x and a y. But they are both equal to something with z on the other side, and that's pretty important. So if we can somehow substitute these equations into the top equation and get only something with z, then that should work for us. So if you look at the top equation, we have x, a y, and a z, but we are able to replace the x and the y based on the 2 equations we have below it. So this second equation is going to go the 2z plus 2, which I should probably erase this now. The second equation, x equals 2z plus 2, we can plug that in for x at the very beginning of the first. At the same time, we're going to do the same thing with the bottom equation. This negative 4z is going to go up here for y. So as we write this out, we're going to replace both these at the same time, and we're going to have only an equation with z in it. So it's going to be 2z plus 2 minus 2, and then multiply this out. Instead of using y, we're going to use this negative 4z equals 9. Oh, sorry, I missed one. Forgot the end part here, which is plus 4z equals 9. Now, I know it's a pretty big equation here, but all we have here is z's. And once you have an equation with only one variable, we can then solve for that variable. So let's do some multiplication here. We have negative 2 times negative 4. That's positive 8z plus 4z equals 9. 2z plus 2. All these z's can be put together. So we have 2 plus 8, which is 10, plus 4, so we get 14z plus 2 equals 9. Subtract 2 on both sides. 14z equals 7. Divide by 14, and we get a z value of 0.5. So I think we did like all the hard work on this one. Now we just have to go through and find the other variables and their values. So now we have z is 0.5. We're going to plug that into either one, the second or the third equation. We actually have to do both anyway. So let's go back up to the second equation. That's x equals 2 times z, which is 0.5, plus 2. So we'll finish that one out, and we get x equals 2 times a half is 1, plus 2 equals 3. So now we know x is 3. Then plug this back in, the 0.5 back into the last equation for y. So it'd be y equals negative 4 times 0.5, and that will simplify to negative 2. So there's all three of the ones we need. So it has an x, y, z, which you don't necessarily have to do, but this would be 3, negative 2, 0.5. So if there's 3 equations and 3 unknowns, you're able to do it and solve for all 3 of them, but you need to have 3 answers in the end. Okay, 2 more, and then I think we'll just do a word problem or 2. So part C, kind of the same strategy, only because if you look at the last 2 equations here, we have a plus 3 and negative 4a, and that's perfect to plug into the top equation. So it's going to be the same thing we did earlier in the last problem. We're going to plug in a plus 3, where we see b right there, and then this negative 4a will go up here for c. Okay, so let's do that. We have 4a plus 6. Don't put b there. We're going to put a plus 3 minus 3, and then not c, but negative 4a equals negative 26. And then we'll distribute, get 6a plus 18. And then negative times negative is going to be a positive 12a equals negative 26. Bring down this 4a. Combine like terms, we have a bunch of a's to put together. 4 plus 6 is 10, plus 12 is 22a, plus 18 equals negative 26. Subtract 18 on both sides. 22a equals, and when you put these together, you're going to get negative 44. Divide by 22 gives you negative 2. Now that you know it's negative 2, we can go ahead and plug it back into these bottom 2 equations. So we're going to do b equals negative 2 plus 3, or you could have c equals negative 4 times negative 2. So the b value would be 1, and the c value is 8. So let's rewrite it. So b is 1, c is 8, and a is negative 2. Okay, so we have one more to go before we get to our word problem. This one is going to be a different kind of approach because the top 2 equations both have 3 variables. That's not great. The bottom one only has 1 variable, so we can at least do something with this bottom one first. I would just move the 1 over so we get a z value. So we can easily get a z value of, by subtracting the 1, it'd be z equals negative 1. Now that we know one of the answers, we can plug that into the top 2 equations for z, and that will help us a little bit. So I'm going to rewrite the top 2 equations, but put negative 1 in there instead. Okay, let's go down here. So we have x plus 2y plus negative 1 equals 6. The next equation would be x minus 4y minus a negative 1 equals 2. So let's simplify this one a little bit. Let's try to rewrite them over here. We have x plus 2y. We'll add the 1 to both sides to make it a 7. On this one, it's already a positive because you have a double negative. We'll subtract it. X minus 4y equals 1. At this point, to compare these two, these two we have. It's probably best just to get one of these equations solved for x and then substitute that back into the other one. So now we're only looking at these two equations. So let's just take the bottom one and solve that one for x. So we're going to add 4y to both sides. I'm going to run out of room, so I'm just going to probably skip this little step here. If you add 4y, you get 4y plus 1 equals x. Once you do that, we can take this whole quantity and substitute that into the top equation we have up here for x. So it's going to go up here. So it would be 4y plus 1 plus 2y equals 7. Combine like terms, we get 6y plus 1 equals 7. Subtract the 1, we're going to get 6y equals 6. Or divide by 6, you get y equals 1. Then you can plug that back in to, well, I guess it doesn't really matter which equation you pick. Plug a y equals 1 into one of these equations. We can go back to this one over here if you want. Or actually, might as well just do this one here. So it'd be x equals 4 times 1 plus 1. X equals 4 plus 1, which is 5. So we have them all. We have 5 as x, y is 1, and z is negative 1. Okay, for the word problem. Now, normally, the word problems do not include the system of equations, but these ones did because I thought they would be more difficult to maybe come up with on your own. So we're going to read through it, and then we'll look at the equations below. So a Valentine bouquet of 24 flowers contains pink carnations, red roses, and white mums. There are half as many mums as carnations and 4 more roses than carnations. So this sentence here is basically giving you the equations that are down below here. If C is the number of carnations, let C be the number of carnations, R be the number of roses, and M be the number of mums, solve the system for each type of flower. So this strategy here is going to be very similar to B and C, I think. Because if you look at the last two equations, they both have C's in them. So we're just going to take what they're equal to and plug it in for M, take what this one's equal to and plug it in for R, and we'll have one nice big equation just with just C's in it. So the new equation on top would be C plus R, which is C plus 4, plus the M value we can change out to 0.5C equals 24. Let's add the C's together. We have 1C plus another C plus 0.5. That's 2.5C plus 4 equals 20. Whoops, 24. Then we can subtract both sides by 4. So it'd be 2.5C equals 20. Divide by 2.5. And that means C is 8. Of course, I think after doing like this one big step, like everything else is a lot easier. We can plug in 8 for both C's in the last two equations, going back to those. So the M value would be 0.5 times 8. Half of 8 is 4. And the R value would be 8 plus 4, which is 12. And just as a check, remember, if you go back to the top equation, this should hold true. If you add the carnations plus the roses plus the mums, it should be a total of 24. And do we get that? 12 plus 8 is 20, plus 4 is 24. So all these added together should be 24, and it is. So there's 8 carnations, 4 mums, and 12 roses. Okay, we'll do one more. And then you can finish number 4 and the challenge. See if you can figure that one out. 3. Mr. Baker makes a total of 160 dozen regular muffins, mini muffins, and jumbo muffins for his stores each day. He makes twice as many regular muffins as mini muffins, and 5 times as many jumbo muffins as mini muffins. So again, this sentence up here is basically giving you the equations down below. R is the number of dozen of regular muffins, M is the number of dozens of mini muffins, and J is the number of dozens of jumbo muffins. Solve the system below. And again, we get M's in both of these, which means we can plug it into the top equation, replacing the letters with the right ones here. Which also 4 would be done the same way. So using our top equation, we would write 2M instead of R, plus M, which will stay there, plus J, which is actually 5M, equals 160. Then combine all the like terms. We have 5, 6, 7, 8. M equals 160. Divide both sides by 8. M equals 20. Okay, now that we know that, it's very easy. These ones I think are even easier than the original 4 that we did on the front page. However, if you had to make up your own equations and make your own system, it might be a little more difficult to do. All right, now we're going to plug this in. So we have R equals 2 times 20, which would be 40. So we have 40 dozen of regular muffins. And then J, we'd have J equals 5 times 20, which would make it 100 dozen of the jumbo muffins. And if you were to add all 3 of these together, you should get a total of 160, which you do. 100 plus 40 plus 20. So R is 40, J is 100, M equals 20. That's all 3 of them. There's one more for you to do as well, kind of the same idea as the last 2. And the very last problem, it's a challenge problem. To get you started with this one, you should look at it and try to figure out, how can I get the same variables like we do in the other ones up here? Like there's 2 M's. Can we get that to happen down here to plug them into the top equation, which is more complicated? So if you look at the second equation, it has Q by itself. So this side has a P. You should probably do the same thing to the bottom here. Get P along with everything else on one side. So I would get R by itself by dividing by 2. So now if we rewrite this is R equals 3P over 2. Now we have something that works, because this can go in for the R at the top here. And the second equation, we can put in the 4P minus 20, where the Q is right above it. And the other part, it just has a 3P. So you can then make an equation with only P's. Solve for the P's and then work your way backwards to get Q and R. So that is all for part 2, using 3 variables and 3 equations and solving systems. And on top of doing the last 2 problems, you should also work on the homework page, which will be posted on Teams as well.